Why is the night sky black? A question that has kept astronomers up at night for centuries. Just kidding. Astronomers don't really need sleep, but it is an excellent question nonetheless. You might think it's easy to answer. After all, we have seen this question coming for millennia. You could be forgiven for thinking that someone would have figured it out by now. But answering why the night sky is black isn't as simple as you might expect. There are many different answers depending on what aspect of the night sky blackness you are most interested in. The universe is unimaginably huge. Even if you doubled your height and jumped up really high, you wouldn't get very far towards the nearest star. And that's just the distance between you and the stars. It's much, much further still to the furthest reaches of the observable universe. That vastness makes it very unlikely that any single star is close enough to us to illuminate the night sky. But can we really say that it's impossible? When the sun is shining, everything seems brightly lit because its light bounces off of every available surface. Sunlight reflects off of clouds, dust particles, water droplets, and even tiny molecules of gas. As long as these particles are smaller than the wavelength of visible light, they will scatter that light away like a tiny mirror. This is why the sky is blue during the day. The particles in our atmosphere scatter blue light more easily than other colors, so the blue light gets bounced away and makes the sky look blue. So if there are particles in our atmosphere small enough to scatter sunlight, why doesn't that same thing happen at night when there are no longer any photons from the sun to scatter? Well, it's because the particles need to be charged to scatter electromagnetic radiation, like light. Normally, the air molecules in our atmosphere are electrically neutral, meaning they don't interact with each other very strongly. During the day, some of the molecules in our atmosphere do get ionized or charged, but not nearly enough to make the night sky glow. There are, however, some parts of the universe that are filled with a large enough number of charged particles to cause the sky to glow, creating nebulae, glowing clouds of gas and dust. They come in all shapes and sizes, from the Crab Nebula, which is the remnant of a supernova explosion, to the Eagle Nebula, home to the famous pillars of creation where new stars are born. These beautiful objects are usually only a few light years across and very distant from Earth. So while they are large, they aren't close enough to illuminate the entire night sky. But then there's the aurora. These spectacular displays of dancing lights occur near Earth's poles and stretch for hundreds of kilometers across the sky. They happen when charged particles from the sun stream into the upper layers of our atmosphere and interact with the gas molecules there. But although auroras can cover a large area, they are only a few kilometers wide. So again, while they do illuminate a large part of the sky, they aren't big enough to cover the whole thing. Finally, there's the most obvious reason that the sky is dark at night. Space is full of stars. Every point of light in the night sky is a star. In fact, the stars are so numerous that there are literally trillions of them, and all those stars emit light. In theory, their light should add up and make the night sky brightly illuminated. But that doesn't happen. Why? Well, in part, it's because space is so big. All those stars are incredibly far away from Earth. That means their light is very dim when it reaches us, even though they're incredibly bright. If you've ever seen a candle flame from far away, you know what I mean. It looks tiny and insignificant. That's because light loses intensity the further away from its source you get. It spreads out over a larger and larger area, which makes it less bright. And space is so big that the stars are ridiculously far away from us. Even the closest stars are 4.37 light years away. That's 4.37 times the distance light takes to travel in 1 year. At that distance, the stars look like tiny pinpricks of light. They seem almost one-dimensional, like you can only see the light coming from one side of them. We call this being in a stellar two-point perspective. In this perspective, the starlight appears to come from a flat plane directly opposite us. This plane is called the celestial sphere. On this sphere, half of the points of light represent stars that are actually in front of us, and half are in back. We don't know which is which. For example, Proxima Centauri, the closest star to the sun, is in front of us. But Alpha Centauri A and B, which orbit around Proxima, are behind us. However, on the celestial sphere, they appear to be next to each other in the sky, and we can't tell which one is in front or behind. This two-dimensional view of the night sky gives us another reason why the sky is dark at night. Stars have atmospheres too, and as light passes through them, it gets absorbed and scattered by atoms in the star's atmosphere. Some atoms absorb visible light, but others only absorb ultraviolet or infrared light. These atmospheric layers act as filters, only letting certain kinds of light pass through. That means that by the time the starlight reaches us, it might be completely different from what came out of the star. Stars also have magnetic fields. These fields affect how light passes through their atmospheres. Sometimes the magnetic fields focus light in one spot. This is called gravitational lensing, and it can make distant stars look huge because the light coming from behind the foreground star is magnified. Gravitational lensing can also make stars appear twice. Once for the light that passes around the magnetic field, and once for the light that passes through it. This splitting is called a binary star. All these effects can change how the night sky looks to us, but the main reason that the night sky is dark is because space is so big. Starlight is so faint that it blends together, creating a murky darkness. With the naked eye, you can only see the brightest stars. But if you use a telescope, you can pick out much dimmer stars and see that the night sky isn't truly black. It's filled with countless stars that are too faint to see with the naked eye. But even if you could see all the stars, they wouldn't make the night sky brightly lit. That's because the night sky is filled with even more empty space. Each star is separated from its neighbors by huge distances. That means that even if you could see all the stars, the sky would still be mostly dark. So there you have it. Space is dark because it's empty. And it's empty because space is dark. Or maybe it's the other way around. Anyway, you get the idea. Of course, this is only one possible answer to the question. There are many others. For example, you might be wondering about cosmic microwave background radiation, or the lack thereof. I didn't mention that because the cosmic microwave background isn't visible to the human eye. It's too cold to be anything but infrared radiation. Plus, it would be hard to see anyway because the sky would be filled with infrared telescopes. Or maybe you're wondering why the sky is dark inside a nebulae. I didn't mention that because it's a whole other topic. Basically, it has to do with how the gas molecules inside of nebulae absorb and re-emit light. The bottom line is that there isn't one simple answer to the question, why is the night sky black? But that doesn't mean the question isn't worth asking. After all, the night sky is one of the most beautiful things to look at, and it's only by asking questions about it that we learn more about the universe we live in. If you want to learn more about the night sky, check out our website. We have a ton of resources there, including a guide to the constellations, a glossary of astronomy terms, and even a tool that lets you see what the night sky looked like on any given night in the past or future. Thanks for watching this video. I'm the host. This has been Life Noggin. Don't forget to keep on thinking.